let's talk about data types and data structures. Recall that um, variables are memory locations in random access memory or RAM, and programming languages need to decide how to store data in ones and zeros, since all data in computers, digital computers, is stored in bits, which can only take two values, one or zero. For example, the number 42, the integer 42, is going to be stored as 101010. And if you want to store characters, such as the characters displayed here, you actually need a code which says which number is going to be used to represent each character. And this, the code is actually called the American Standard Code for Information Interchange, or ASCII, and it looks something like this. So a big A is represented by the number 65. Of course, not in decimal digits, 6 and 5, but in binary with ones and zeros. Or the little a is represented by the number 97, and so on and so forth. The point is that how a variable is actually stored in RAM depends on what type it is, and therefore each variable that we create has a data type. And there is a function in R known as type of that can be used to determine what the data type of any particular variable is. So, for instance, let's insert a code chunk and um, check the what data type the variable we created before to store the number of hydrogen atoms in a picogram of hydrogen gas, what its data type is. And if I call this function type of with its argument, which is numHeight atoms, and run this code chunk, it returns something known as double. And double stands for double precision, which means this is the data type that is used to represent any real number, whether it be rational or irrational, so things with decimal points. Um, then let's see another data type, which is the integer data type. And we can create an integer. Let's say we'll call it num students is the name of the variable. Then we have the assignment operator, and we will assign the value negative 34. Um, in order to distinguish between a double precision and integers, you add this big L to the number to tell R that this is in fact an integer and not a double precision. And I can assign this, and then I can do type of num students, and you can see I can actually complete this by pressing tab. I don't have to type the whole thing out. And if I run this code chunk, it'll tell me integer. Then there is another data type called logical, and logical variables only take two values. They can either be true, and you have to write this in capital letters, and you can see this thing turned blue, which means this is a reserved keyword. True and false are reserved keywords that stand for true or false logical values, and cannot be used for anything else. And I can do type of for past, and if I run this code chunk, you can see that past is a logical variable. And finally, we can talk about character variables. And um, character variables, if it's just one character, is called a character. But when you have more than one character, it's called a string, for string of characters. And let's store this a name James in a variable called student name, and we have assigned the name James to this variable student name, and then we can do type of and run this code chunk to see that it's of the type data type character. Now, one very important thing to keep in mind is that when you have character data, you have to always enclose it in quotes. So, for example, I have typed James here, which is my character data, and I have to enclose it in quotes. If I do not enclose it in quotes and try and run this chunk, I get this error, object James not found. And the reason is variables like student name and functions are also characters. We are using characters to represent variable names and function names. So how does R tell whether when we have typed a character, whether it's a variable name like student name or whether it's data like James, or another word that's used is it a literal string? Is it a data string? And the way we tell R that something is a literal string or data is by enclosing it in quotes. So if it's not enclosed in quotes, R assumes that it's a variable. And in this case, what happened was it thought that James is a variable or a function, but no such variable or function exists. So R gave us this error that it could not find this object James. On the other hand, when we include James in quotes, then R knows that this is a literal string or data, character data, and it takes this character and stores it in a memory location given by the variable student name. Next, let's talk about data structures. Very often, it is necessary for us to deal with large sets of related data points. For example, we may want to store the scores of 100 students in a class. Now, one could create 100 different variables, each with its own name. So there would be 100 memory locations, each with its own name, to store data such as this. But that would be very difficult and unwieldy to deal with because we would have to individually manipulate 100 different variables, and we would have to keep track and remember 100 different variables. And that's not a practical approach. So R provides a way to organize large sets of data under a single variable name. And this way of organizing data, multiple data points under a single variable name, is known as a data structure. So let's discuss one such data structure, which will come in very handy, and they're called vectors. So let's start to work with vectors. Now, a vector can be created by the combine function. So let's go ahead and insert a code chunk, and we will create a vector called student course using the combine function. And so we can give some scores, and then in the combine function will combine individual values into a vector. Then we can use the type of function to check what the type is, and in this case it's double because it's a vector, but the type of data stored in this vector is that of double precision numbers. We can also um, echo the variable by typing its name and executing the code chunk, and we see that this variable contains not one number or one data point, but actually 10 different data points. And The reason this is called a data structure is that it is stored in memory in a particular structure. And the structure looks something like this, that each number is stored in consecutive memory locations, and you can define or address the position of each memory location by something known as the index. And that's why we can refer to 10 numbers, 10 data points, all under one name, which in this case is student scores. So then, how do we use a variable that is a data structure like this vector? And one thing you may want to do is you may want to retrieve a particular value. So maybe you want to know the score of the third student. So you want to know the score at the third position, or having index 3. And the way you do it is you take the variable name and you use square brackets, and you put the index number of the position in within the square brackets. So if I say student scores 3, it says give me the third data point, the data stored in the third position of this vector. And so if I execute this code chunk, I will get the score of the third student, which is 91. You can also um, retrieve a range of scores. So let's say we want to print out the scores of the second through the fifth students. So we want second, third, fourth, fifth. And the syntax for doing that is you give the starting position, which is 2, then you give a colon, and then the ending position, which is 5, all within the square brackets, because the square brackets provide the index that we want to, or the position that we want to retrieve. And now, if I run this code chunk, I get a vector of 4 positions from the second to the fifth position. Now, you don't just have vectors of numeric data, or in this case double precision data, but you can have vectors of all other data types. For example, we could create a vector called student names, use the assignment operator, and now use the combine function to give student names, let's say A through J. This would be a vector, and then we can also check what is the type of this vector. And when we execute this code chunk, it shows me that we have created a vector which has a data type of character. And um, you would index or access values in this vector in exactly the same way as we did with the numeric vector. So for example, we could want to print out the second name. And so I would say student names, use square brackets, and the index 2, which is the second position in this vector. Um, and perhaps I want to print out the sixth through the ninth names. And I would do that by having the variable name, square brackets, and starting position 6, colon, ending position ninth. And when I run this code chunk, it indeed prints out the second name, which is B, as well as the sixth through the ninth names. So it doesn't matter what type of data a vector holds. It could be integer, it could be double precision, it could be character or string data, or it could be logical. You work with them the same way. You access values within the vector using the position or the index into that vector. Next, let's talk about a very, very important data structure, which is called a data frame. And it would be an understatement to say that pretty much all the work that we would be doing in R will be with data frames. In fact, all of this introduction to variables is really just a build up to introduce data frames and make you familiar with and comfortable with working with data frames. So the first step would be to create a data frame. And what a data frame looks like is, so if the vector looks like a list of data points, whether it is numbers or characters, a data frame is a collection of vectors. So it looks like a table. And a table is made up of rows and columns, and we can create a data frame using a function called data.frame by specifying the columns. So let's create a data frame called student results. And we have the assignment operator. Then we have the function data.frame. And we will give the first column as the names of the students. So the syntax is you say the name of the column, you'll say names equals, and you give the vector containing the data that goes into this column. In this case, we will give the vector, the character vector, student names, and then we want the second column. That column should be called scores, and we give an equal to sign, and then the vector that contains the data that goes into that column, which is student scores. And this would create this data frame. And let's just type this name and echo what this data frame looks like. So if I run this code chunk, now you see we have created a data frame with two columns, one containing the names of the students and the other containing the scores of the students, and each row corresponds to one student. And so this is a very simple data frame. There are many ways to inspect data frames to understand the properties of data frames. So let's look at some of them. There is a function called enrow, and the argument to this function is the name of the data frame. This provides the number of rows in this data frame. So if I run this code chunk, it gives me the answer 10, which is the number of rows this data frame contains. There's another function called encall, which gives the number of columns. And once again, when I run this code chunk, it gives me the number of columns, which is 2. Another very useful function is summary. Now, this data frame that we created, this toy data frame, has just 10 rows and 2 columns. But as the class progresses and we start dealing with realistic data sets, those data frames are going to be huge. They could have thousands of rows, and it's not possible to simply echo these huge data frames to look through them. So a useful function is summary, which summarizes the properties of a data frame. In this case, when we run summary, it shows us that there are two columns called names and scores, and that the first column has a length of 10. So there are 10 rows, and it's a character. And the second column scores, it shows us, since it's a numerical or double precision column, it shows us the statistical summary, minimum, max, median, mean, and so on. Finally, one more function to inspect big data frames is called head, which basically shows you the first few rows of a data frame. And that's another good way to get a handle on what a data frame is about. Finally, let's discuss how you can access individual parts, individual data. Since this is a collection or data structure that contains many data points organized in a table, how do we access individual values of this data set? So the first question is, how do we access an individual element which may be in row I and column J, and we will still use the square bracket notation, but now we have two indices instead of one index, as in the case of vectors. And the first index tells you the row, and the second index tells you the column. So let's say we want to print out the fifth student score. So we want the fifth row. So we put 5 for the first index that tells us which row it is going to be. Then we put a comma to say to separate the two indices, and now the second number is going to be the column, and we want the score. So we don't want the name, which is the first column. We want the score, which is the second column. So we put down 2 down there, and when we run the code chunk, we get the fifth student score, which is 85. Um, you can also print out an entire column. You may want to access the entire column, and the way you do it is you basically omit the row number. So if you leave the row index blank, then you can print out the entire column. So we could print out the second column, which is all the scores, by giving solid bracket open comma and the number of the column we want to print out, which is the second one here. Another way to print out an entire column is to use the column's name. So we can say student results. And now instead of square brackets, we use the dollar notation. So we can say dollar, and the dollar is followed by the name of the column. And in this case, it's R is automatically showing us the possible column names of this data frame. We want the scores in this case, so we use tab to select scores, and then when I run the score chunk, it shows me the value stored in the scores column. Lastly, you may want to print out an entire row, and we can do it the same way as printing out an entire column, which is by omitting the other index. So let's say we wanted to print out the name and score of the last student, which is we want the 10th row because there are 10 students. We want the 10th row, but we want all the columns. We want the entire row. So we will omit the index for the second index for the column. And when I run this code chunk, I get just the last row, which is the name and the score of the 10th student.